Part E. Here we're told that it can be assumed that the survey results are representative of the population of the city and that 10 people are chosen at random in the city. 10 people in the city are chosen at random, and we have to find the probability that at least 5 prefer dark chocolate. So when they say the results are representative of the population, basically these probabilities will be the same so these probabilities of the 160 people surveyed will be the same out of everyone in the city. So for example, we surveyed 160 people. 12 of them, or 48 of them, are children who prefer milk chocolate. So 48 out of 160. And this is equal to 0.3. So basically, 30% of the people surveyed are children who prefer milk chocolate. Um, and this is going to be the same if you surveyed everyone in the city. So if there's, for example, a million people in the city, then 30% out of everyone in the city will be children who prefer milk chocolate. So anyway, what's the probability that a single person prefers dark chocolate in this case? Well, we see that there's 12 plus y, so probability of dark chocolate is equal to 12 plus y out of everyone surveyed, so out of 160. Now in part C2, we found the value of x was equal to 24, and we can use this to find y. Well, x plus y equals 100, looking at our table here. There's 100 adults, and this we found in part A. 100 adults, 24 of the adults prefer milk chocolate, the rest Y prefer dark chocolate. So let's see. X plus Y has to be 100. X is 24, so 24 plus Y equals 100. And Y, therefore Y is equal to 100 minus 24, which is 76. So the probability that a person prefers dark chocolate is 12 plus 76 over 160. Now let's see what this is equal to. 12 plus 76 is 88, so 88 over 160. And this is equal to 0.55. So the probability that a single person prefers dark chocolate is 0.55. We're going to choose 10 people, and we have to count how many prefer dark chocolate. So this is going to be a binomial distribution. We have a repeated number of trials. So 10 times we're going to be choosing people and asking which chocolate they prefer. And each time you choose someone in each trial, we have a fixed probability of success. So 10 independent trials, each trial has a fixed probability of success. In this case, probability that they prefer dark chocolate, which is 0.55. So let's introduce a random variable x equal to the number of people who prefer dark chocolate, who prefer dark chocolate. X is going to be binomially distributed with 10 trials and 0.55 probability of success in each trial. So I'm just going to say here n, which is the number of trials, is 10, and lowercase p, the probability of success, or the probability that we satisfy a certain criteria in each trial, 0.55. And what we're looking for is the probability that at least 5 of them prefer dark chocolate. So the probability that x is greater than or equal to 5. And we can find this with the calculator. So we go here to our calculator, menu, statistics, distribution, binomial, and then BCD, since we're doing a cumulative distribution. We're not doing the cumulative probability. We're not doing probability that x is exactly 5, but that x is greater than or equal to 5. So it could be 5, 6, 7, 8, all the way up to 10. So let's see. Binomial CD, our lower bound is 5, and our upper bound would be 10, because we can't have more than 10 people preferring dark chocolate if we only ask 10 people. Num trials n is 10, and lowercase p is 0.55. We have these values here. Execute, and we get 0.738437. So rounded to 3 significant figures, 0.738. So that's the answer to part E. Probability that at least 5 people prefer dark chocolate is equal to 0.738.